Welcome to the video that will finish the notes for operations with radicals. In class, we had worked down through example 3C, and so I'm now going to start with example 3D, which would be on the second half of the first page. And what we had talked about is splitting the things under the radical into a perfect square factor and a non-perfect square factor. So we preserve the 5. We can split 32. The biggest perfect square factor is a 16, and that multiplied by 2 is 32. And 128 might be intimidating at first, but if you take a 2 out, then what you have left is a 64. So we can split that further. Square root of 16, square root of 2, minus square root of 64, square root of 2. And you know the square root of 16 is just 4. So 5 times 4 times the square root of 2 minus square root of 64 is 8. Square root of 2, and that would be 20 root 2 minus 8 root 2, and 20 minus 8 is 12 root 2, and that's our answer. Okay, let's work through some practice. I know that we did this in class, but actually I'm going to erase it, and we'll go ahead and go through it again. But in the meantime, let's go ahead and start here. So we're looking for that perfect square factor within 27, and you've probably realized that it's 9 times 3, and 9 is our perfect square. Plus 2, and our perfect square here is 25 times 3. So if we split that, square root of 9, and that's root 3, plus 2, root 25, root 3. So the square root of 9 is 3 times 6 is 18. Square root of 25 times 2 is 10. And then we can add 18 and 10, and we get 28 root 3. Okay, let's move on to the next one. I bet that you recognize this one as square root of 25 times 2. You may not recognize this one to begin with, but if we divide 98 by 2, we get a 49, and that is indeed a perfect square. So square root of 25, square root of 2, minus square root of 49, square root of 2. Square root of 25 is 5 times that root 2. Square root of 49 is 7 times that root 2. And we add those together and we get negative 2 root 2. Okay, let's go through this one again. So that's square root of 55. We can't simplify that, so we're going to work with this one first. And that would be 7. And we're going to split that root into a numerator root and a denominator root. And then, if you recall from what we've been doing, we have to get rid of that square root in the denominator by multiplying by a clever version of 1. And our clever version of 1 is root 11 over root 11. So we're going to multiply across here, and I'm just going to carry that negative 55. I'm sorry, the positive 55. And that's minus 7 times 5 times root 11. Actually, that's root 5, root 11. and root 11 times root 11. So we're still carrying that positive 55, or root 55, and let's work on simplifying this. So I have a 7. We can combine the root 5 and the root 11 under one root. But 5 times 11. And root 11 times root 11 is just plain 11. Okay, we're still working on simplifying this, and then we'll combine that fraction. So that's root 55 minus 7 root 55, because I multiplied that 5 times that 11, I'm sorry, right here under the root, over 11. Now in order to combine these, we're going to have to put that root 55 as a fraction over 11. So we have to have like denominators. So I'm going to multiply, I'm going to give myself a little space here. Give that a little itty bitty minus, and I'm going to multiply that by 11 over 11. So if we put that over 1. So this becomes 11 root 55 over 11 minus 7 root 55 over 11. So since they're both over 11, we can just take 11 minus 7 is 4 times root 55 over 11, and that is our answer. Okay, let's get to work on the next one. The perfect square in 8 is 4 times 2. Okay, and this one, we need to split that root into a numerator root and a denominator root. And then we're going to multiply it by the clever version of 1, which is the denominator here, the denominator over itself, which is 1. So simplifying 4 times 2, you get 2 root 2. And that root 1 is just 1. So we have root 2 over root 2 times root 2. So root 2 times root 2 is, I'm just copying this one first, root 2 over 2. Now we've got 2 root 2 minus root 2 over 2. So if we convert this to a fraction over 2, then we can add these two terms together. So I have 4 root 2 over 2 minus root 2 over 2. And there's only one of those, so we can put a 1 here. So the answer is 3 root 2 over 2. Okay, let's look at number 5. So we have 3. 18, I bet you've already guessed, can be split into 9 and 2. And then we're going to split this up and down. Root 2, root 25. So on our next step, that square root of 9 simplifies as 3. So 3 times 3 root 2 plus root 2 over, what's the square root of 25? I bet you guessed it. That's 5. You didn't have to guess it, you could just calculate it. So 3 times 3 is 9 root 2 plus root 2 over 5. So if we make this into a fraction over 5, then we can add those together and simplify. So you could put the 9 over the 1 and then multiply by 5 over 5. So you get 45 root 2 over 5 plus 1 root 2 over 5. 45 plus 1 is 46 root 2 over 5. And that's the answer. Okay, now this one. This one, the 2700 may look intimidating, but if you play around with it a little bit, you're going to realize that 900 is a perfect square. And you multiply 900 times 3, and you get 2700. And we're going to address the 4 times the root of 1/3, and we're going to split that into an upper root and a lower root. So we know after we split it that we can multiply. We have to get rid of this root 3 in the denominator. So we're going to multiply by root 3 over root 3. Okay, square root of 900 is 30 times root 3 minus 4 root 3 over root 3 times root 3. And that's this denominator simplifies as just 3. So 30 root 3 minus 4 root 3 over 3. Now we can combine these because these are both square root of 3. We can combine them by finding that common denominator, which is 3. So this is 90 root 3 over 3 minus 4 root 3 over 3. And since the root 3 is the same and the over 3 is the same, we can say 90 minus 4 is 86 root 3 over 3. And that's our answer. So let's move on. And I can already see that there's going to be a second video here, but it will be a short one. And we're going to practice simplifying binomials. And you guys know how to do this. You just distribute. So root 2 times root 2 plus root 2 times root 5 is our first step. Root 2 times root 2 is just 2 plus, and when you have a root times a root, you can combine those under the same root. So our answer is 2 plus root 10. Okay, let's do this one. Root 6 times root 3 minus root 6 times root 2. So root 6 times root 3 is root 18 minus 6 times 2 is 12. Now, we've seen these before, and we know that we can simplify what's underneath the root. So 9 and 2 minus, and you know 4 and 3. So the square root of 9 is 3 with the 2 left under the radical. Square root of 4 is 2 with the 3 left under the radical. And you know from our previous lesson that you cannot combine root 2 and root 3. So this is as simple as it gets. So tune into part 2 for the rest of the story.